When you're able to write an equation, you can use that equation to make predictions about the future. Now we're going to focus now on writing an equation in slope-intercept form and how we can use real-life data, put real-life data into that equation. If you look at this example, it says the number of trout in a lake was estimated to be about 44.5 thousand in 1995. During the next 10 years, the trout population is expected to increase by about 3.2 thousand per year. Now it wants us to write an equation to model the trout population between these years. So let's focus. The equations we're writing right now are in slope-intercept form. Y equals mx plus b. Now what we know is we need to fill in a value for our slope m and our y-intercept b. The good news is you really don't need to figure anything out. I'm going to give you a hint. Our slope is m. Okay? The slope, if you think way back to when we worked on some other things, slope is the same thing as your rate. So if you read the given information up here, you come across this. It's increasing by about 3.2 thousand per year. So remember, slope tells us how much something is changing, right? And so this is telling me it's changing 3.2 thousand per year. So that's your slope. Whenever you see a rate, you see the word per or for each or something like that. That's your rate, that's your slope. So down here, I don't need to figure out what my slope is. It tells me it. It's 3.2 thousand. You know, they're both given in thousand, so I don't have to worry about writing that out. Okay, but again, slope tells us how much something is changing. This is how much it's changing, 3.2 thousand per year. Another hint, your b, remember, is your y-intercept. Your b is also your initial value. Your initial value. Now what do I mean by initial value? I mean starting point. If you read the information, it says the number of trout in a lake was estimated to be about 44.5 thousand in 1995. So that's where we're starting from. The number of trout we're starting with is 44.5 thousand. So you don't need to figure that out either. You can just plug it into the equation. So this equation becomes y equals 3.2x plus 44.5. Use these hints to write your equations. You don't have to figure things out. Slope, that's what m stands for, tells us how something is changing. That's the rate. It's changing 3.2 thousand per year. So we just plug in 3.2 for m. Our y-intercept, our b, is going to be our initial value. So you just read the information to find out where you're starting from. I'm starting from 44.5 thousand. So that's your b. Now once we have this equation, and I honestly, since it says let t be the number of years since 1995, I should actually write this as a t in here. Okay. That's not necessarily a big deal, but it does tell us it says let t be the number of years since 1995. Now we can use it to predict the trout population. Okay, so maybe I'm going to change this y into a p for population. Okay, so predict the trout population in 2002. We don't just plug 2002 in for here, because remember, we're talking about the years since 1995. So how many years since 1995 is 2002? Hopefully 7 years, right? So we're going to plug in a 7 into this formula. So our population is going to be 3.2 times 7 plus 44.5. And if you type that into your calculator, we come up with 66.9. Now remember, that just doesn't mean there's almost 67 trout. These were given in thousands. So this is 66.9 thousand. And this is just an estimation. This is a prediction, I should say. Okay? We don't know for sure what's going to happen. Maybe there'll be a disease that comes into the lake and kills out a bunch of trout. Maybe some new food source comes in and there can be an increase in the number of trout. But based on the given information here, we can predict that there will be 66.9 thousand trout in that lake. Again, using a slope-intercept form to write an equation. Let's look at one more example. It says an electrician charges $66 for the first hour of service and $45 for any additional hours. We're going to write a linear model, so we're writing an equation using slope-intercept form to reflect the electrician's charges and use the equation to determine the cost of a 3-hour service call. Okay, so let's write the equation. Remember, addition can be in any order, so it doesn't matter if your b comes first or your mx. This is traditionally how we say it. But if I'm reading this problem, I'm going to say, you know what, I'm going to pay $66 for the first hour. Okay, and if you call the electrician, once they're there, you're paying for an hour. So I'm going to pay $66. That's not changing. I'm going to pay that $66 once. But then I'm paying $45 for any additional hours. That can change. If it's one additional hour, I'll pay $45 times 1. If it's 2 additional hours, I'm going to pay $90 because that's 45 times 2. If it's 3 additional hours, well, I'll pay $135 because that's 45 times 3. Notice that's changing. If it's changing per hour, remember that's a rate, that's our slope. And we can just set this equal to y. Now let's talk about what this is. Our cost is going to equal $66 plus $45 per any additional hours. 66 for the first hour, we pay that, and then $45 per hours. This again is our slope. This changes. That's our rate. Okay? Now if you want, you can always change the variables. You can say the total cost is going to equal $66 plus 45 times number of hours, something like that. Okay? Now be careful with this equation. Okay, so we have our equation, and it says use the equation to determine the cost of a 3-hour service call. That doesn't mean that you plug 3 in here for h. Remember what it says. You're going to pay $66 for the first hour, 45 for any additional hours. So our total cost is going to be $66 for that first hour plus 45 times how many additional hours? Well, if it's 3 hours total, we paid it 66 for the first hour. There's only 2 additional hours. Okay, so just be careful when you're setting up equation. You really could say that, you know, maybe this was, instead of h minus 1, you could somehow define it like that, but you don't need to. This is easier to graph. You just have to make it known that it's $66 for the first hour. Okay, and if you can just reason through that and know to put a 2 here, that's fine. Okay? So then you just plug it into your calculator, 66 plus 45 times 2, and you get $156. So again, setting things up in slope-intercept form, knowing the hints of that your rate of change is your slope and your initial value is your y-intercept, helps you set up the formula. And once you have a formula, then you can use it to make predictions about the future.